Welcome to Engineering Mechanics tutorial. Today we are going to discuss about part 4 of chapter 2, resultant of force systems. The topics for this session are the resultant of force system. Under that are the resultant of parallel force system and the resultant of concurrent force system. Resultant of force system. It is that single force having the same effect in translation of rotation of all applied forces. Resultant of parallel forces. So this is the formula for the parallel force system. R is equal to summation of F and summation of M is equal to RD, where R is equal to resultant force, summation of F is equal to summation of vertical forces, summation of M is equal to summation of moments, and D, the distance of resultant with respect to specified axis. So problem number 206, a parallel force system acts on a lever shown. Determine the magnitude and position of the resultant. This is the illustration for this problem. Now, in solving for the magnitude, we must get the summation of all forces of the lever. According to the illustration, 150 Newton is going down, that makes it negative 150. 300 Newton is also going down, that makes it negative 300. 90 Newton is going up, that makes it positive. And 180 Newton is going down, that makes it negative 180. So the total resultant force in the lever is negative 540 Newton. Now, for solving for D, we are going to use this formula. Summation of moments at A is equal to R times D. Going back to the illustration, 150 Newton is going clockwise to point A multiplied with 0.75 meter plus 300 Newton going clockwise multiplied with 1.75. Next is 90 Newton going counterclockwise, that makes it negative 90 multiplied with 2.5 plus 180 Newton going clockwise multiplied with 4, and that will give us the summation of moments of A, which is equal to 1032.5 Newton meter. By substituting the R and the summation of moments at A to this equation, summation of moments of A is equal to R times D, we can get the distance. D is equal to the summation of moments at A all over resultant force. That will give us 2.10 meter. And this is the total. So this is the illustration for the answers in this problem. Next problem, number 207. The beam AB shown supports a load which varies from an intensity of 70 Newton meter to 270 Newton meter. Calculate the magnitude and position. As we can see, the given weight 1 is equal to 70 Newton meter and weight 2, which is equal to 270 Newton meter, and the length of beam AB is 3.5 meter. So the solution to get magnitude and position of the resultant load is first divide the trapezoidal loading into rectangular and triangular loading. Next is determine the weight for each type of loading. By using this equation, for the weight 1 equals weight 2 divided by the length. By substituting the given to the formula, we will have 70 Newton meter all over 3.5 meter. That will give us 20 Newton. In getting the weight number 2 minus weight number 1 all over 2 times length. Substituting the given, 270 minus 70 all over 2 times 3.5. That will give us 28.57 Newton. Now we are going to determine the location of weight 1 and weight 2 by using these formulas. D1 is equal to L all over 2 and D2 is equal to 2 times L all over 3. By substituting the given to D1, 3.5 all over 2, that will give us 1.75 meter. And substituting the given for D2, 2 times 3.5 all over 3, that will give us 2.33 meter. And last step is to draw free body diagram of the loading. So in finding the magnitude, we are going to use the formula R is equal to weight 1 plus weight 2. By substituting the answers earlier, we will get 20 plus 28.57. That will give us a total of 48.57 Newton. Now, for solving for the position of R, summation of moments at A is equal to 20 multiplied with 1.75 plus 28.57 multiplied with 2.33. That will give us a total of 101.57 Newton meter. Now, we are going to substitute the answers in this formula. Summation of moments at A is equal to R times D to get the distance. By revising the formula, D is equal to summation of moments at A all over R. In substituting the answers earlier, 101.57 Newton meter divided by 48.57 Newton, we will get an answer of 2.09 meter. Will be the resultant of concurrent force system, and we are going to use this formula. R is equal to square root of summation of f of x square plus summation of f of y square, and also we are going to use tangent theta is equal to summation of f of y all over summation of f of x. So given problem number 208, determine the resultant of the concurrent system of forces shown and its direction. So for the solution, we are going to get first the summation of f of x. So first, 1.5 kilonewton. This is located at the second quadrant. That will give us negative 1.5 cosine 30 degrees plus 2.2 kilonewton multiplied with 4 all over 5. 5 is the hypotenuse of this right triangle, plus 1.25 kilonewton cosine 15 degrees minus 3 kilonewton multiplied with 3 all over 5.83, which is the hypotenuse of this right triangle. By solving this, we could get negative 1.30 plus 1.76 plus 1.21 minus 1.54. So the total for this is 0.13 kilonewton. For the next, summation of f of y, 1.5 kilonewton sine 30 because quadrant 2 is positive, plus 2.2 kilonewton times 3 over 5 because quadrant 1 is positive as well, minus 1.25 sine 15 because quadrant 4 is negative, and 3.0 times 5 all over 5.83 because quadrant 3 is negative, minus 2.5 kilonewton that is directed down in the y-axis. Getting the total of this, we will get 0.75 plus 1.32 minus 0.32 minus 2.57 minus 2.5. That will give us a total of negative 3.32 kilonewton. In solving for R, we are going to substitute the given to the formula. So R is equal to square root of 0.13 square plus 3.32 square. And we will get a total of 3.32 kilonewton as the total resultant. Next, we are going to solve for theta. With this formula, tangent theta is equal to summation of f of y all over f of x. By substituting the answers earlier, tangent theta is equal to 3.32 all over 0.13. Revising this equation, we will have theta is equal to cotangent 3.32 all over 0.13. Theta is equal to cotangent 25.54, and we will get an angle of inclination of 87.76 degrees. The block shown is acted upon by its weight 900 Newton, a horizontal force Q which is 2700 Newton, and the pressure P exerted by the inclined plane. The resultant R of these forces is up and parallel to the inclined, thereby sliding the block up it. So we need to determine P and R. So this is the illustration for the whole problem. P is 15 degrees below, Q is 2700 Newton, W is 900 Newton, and R is up and parallel to the inclined. So first step, we need to re-illustrate this illustration. So Q, which is equal to 2700 Newton, is located in the quadrant 2 of the Cartesian plane. We can move this towards the quadrant 4 here in this new illustration. Then next is W, which has 900 Newton, which is located in quadrant 1, and we can move this downwards and we can locate it in the quadrant 3, which has 30 degrees. Next is P, which has 15 degrees. We can move this from quadrant 4 to quadrant 2, and R still remains on its same position. Next, we need to get the summation of forces from X and Y axis. So first, in X axis, R is equal to 2700 cosine 30 degrees minus 900 sine 30 degrees minus P sine 15 degrees. R is equal to 2338.27 minus 450 minus 0.259P. And we can get the total first equation for summation of X. So R is equal to negative 0.259P plus 1888.27. So for the summation of Y, P cosine 15 degrees minus 2700 sine 30 degrees minus 900 cosine 30 degrees. 0.966P minus 1350 minus 779.42, and we can get the total second equation, which is 0.966P minus 2129.42. Now, for solving for R by elimination, we need first to multiply 0.966 to the first equation so that we could get 0.966R is equal to negative 0.250P plus 1824.07, which is the third equation. And next is 0.259 multiplied with the second equation. Then we can get 0.250P minus 551.52. By totaling this third and fourth equation, we can get 0.966R, which is equal to 1276.55. And by dividing both sides by 0.966, we could get the R, which is equal to 1317.34 Newton as the final answer for R. So the solution in finding for P by substitution, substituting the R in the first equation, we could get 1317.34 equals negative 0.259P plus 1888.27. 0.259P equals 571.27. By dividing both sides by 0.259, we could get the total of P, which is equal to 2205.68 Newton.